So this video is about similar triangles. The last topic we talked about was similar polygons, but now we're going to talk about similar triangles specifically. Remember that the word similar means to have the same shape but different sizes. And that the symbol for similar is that kind of Enye shape. Similar triangles are triangles that have three pairs of congruent corresponding angles, that's what gives it the same shape, and three pairs of proportional corresponding sides. And reminder that corresponding means that it's in the same position, and that proportional means that the sides have the same ratio. So if we look at this example, the first thing that I like to check is the angles. So I can see that angle A and angle D are congruent. They're both 31. Angle B and angle E are both 82, so they are congruent. And angle C and angle F are both 67, and they are congruent. Now I go on to check my proportions. And the reason that I do that is because checking your angles is an easy comparison. They're either equal or they're not. But doing the work to find out if the sides are proportional takes a little bit more time. So we see that we have AB over DE. So AB and DE, so that's going to be 8 over 4. And that should be congruent to BC, which is 6, over EF, which is 3, and then CA, which is 11, over FD, which is 5.5. And if I reduce all of these using a calculator, I can see that my ratio is going to be 2 over 1. Since they all have the same ratio of 2 over 1, the triangles are similar, so therefore triangle ABC is similar to triangle DEF. And much like when we talked about congruent triangles, notice that the letters match up. So A is in the same place as D, B is in the same place as E, and C is in the same place as F. So if we look at example 1, it tells us that the triangles are similar, so I don't have to prove anything, but it asks me to find all the missing sides and angles. So again, I like finding the angles first. J and M are in the same location, they are both 75. Angle K is the same as angle N, so that's going to be 60. And then to find angles L and O, we've been doing this for forever, it seems. I take 75 plus 60, and I get 135, and then I take 180 minus 135, and I get 45. So angle L and angle O are both 45 degrees. Then, to find the missing sides, I do have to make some ratios. So if I look, I see that if I go from JL to MO, that I have 9 to 3. So my ratio is 9 over 3, and therefore my scale factor would be 3 over 1. So I know that if I'm going from JK to MN, I'm going to call this X, and I can say 6 over X is equal to 3 over 1. So therefore my missing side is 2. And I can call it X, Y, Z, Q, question mark, it doesn't matter. I'm going to use the same method. Now I see that ON is 1. So now if I want to find this side, I know that to go from the smaller shape to the bigger shape, smaller to bigger, I times it by 3, or I can make a ratio. 3 over 1 is equal to question mark over 1. Hey, look at that. Either way, it's going to be 3. Now, if I look at example 2, it's telling me that triangle QRS is similar to triangle XYZ. And it says therefore, and therefore just means what conclusions can I draw? Well, therefore, angle Q is going to be congruent to angle X. And angle Y is going to be congruent to angle R. And angle RSQ would be congruent to angle YZX because they are in the same location. And if I'm going to make my ratios, QR is in the same location as XY, RS is in the same location as YZ, and SQ is in the same location as ZX. When we first started learning about congruent triangles, and now we're moving into similar triangles, we had to have all 6 pieces match. All 3 angles had to be congruent and all 3 sides had to be in a similar ratio. Well, we don't need all that information to prove the triangles are similar. Okay, so we don't need all 6 pieces of information to prove that the sides are similar because we have shortcuts. The first shortcut we have for triangle similarity is similar to the one for triangle congruence, which is side, side, side. So if all 3 pairs of sides are proportional, then the triangles are similar. So how would I check? Well, I'm going to just match up 10 over 5, 8 over 4, and 12 over 6. Each of these reduce to 2 over 1. So that means that they are proportional. So these triangles are proportional by side, side, side similarity. Another shortcut is side angle side similarity. So that means that 2 pairs of sides must be proportional and the angles in between them are congruent. So if I look at this example, I can see that these angles are congruent, and it's always easier to start with the angles. And now I'm going to compare the sides. 9 over 6 is equal to 6 over 4. They both reduce to 3 over 2. Therefore, these triangles are similar by side angle side. And lastly, one that we didn't use for congruence is angle angle. Notice sometimes it's referred to as angle angle angle, but you really only need to know 2 of the angles. So if 2 pairs of angles are congruent, then we can use angle angle. Because if 2 angles are congruent, all 3 of the angles will be congruent because they add up to 180 degrees. So if we look at these examples, are these triangles similar? Well, I have 1 angle, 2 angles are congruent. Therefore, this would be similar by angle angle similarity. If I am looking at number 2, notice I'm not given any angles. So it's not going to be angle angle and it's not going to be side angle side. The only one that it could be is side side side. So I have to check my ratios. 7 divided by 5.25, 12 over 9, and 14 over 10.5. And you might want to use a calculator, but each of these reduces to 4 over 3. So therefore, these are similar by side, side, side similarity. Similar triangles allow us to do algebra to find missing parts. Because if 2 triangles are similar, then their corresponding sides are proportional, which means that I can just make ratios to find the missing sides. For example, triangle ABC is similar to triangle DEF, and we're trying to find the missing side, or X. And it says the triangles may not be drawn to scale because if you take a ruler and measure them, they might not actually be 8 units and 9 units. But that's okay because all we need to do is make a proportion. So I'm going to say AB is similar to DE, so I would say 8 over X because these sides correspond, is equal to 9 over 27 because those sides correspond. And then I'm going to cross multiply and get 8 times 27 is 216, and that equals 9x, and then I divide. And I get that x is equal to 24. Can you also reduce that fraction of 9 over 27 first and then multiply? Absolutely. But not everybody is comfortable reducing fractions, so this method with a calculator works just fine. If we look at the next example, again, it's telling us that the triangles are similar. So it wants me to find A and B. Well, I always start with the angle because it's the easiest. If angle R is 37 and angle X is in the same location, then B is 37 degrees. Then to find A, I would simply make a ratio. I'm going to say A over 6 is equal to 8 over 12. Now I'm drawing the lines here so you can see for the notes what matches up. You don't actually have to draw those if you don't want to. Again, you can reduce 8 over 12 to 2/3 and cross multiply then, or you can just cross multiply and say 12 times A is equal to 48. I divide by 12, and therefore A is equal to 4. And lastly, it says that triangle JKL was dilated by a factor of 2/3. So dilated just means it was made smaller, and we don't even care about that because all we care about is the factor of 2/3. And triangle JKL was made smaller to form triangle J prime, K prime, and L prime. But again, it doesn't matter that these are prime. We just know that the smaller one is 2/3 of the bigger one. And we want to find X and Y. Well, here's 43. Here's Y. So Y is equal to 43 degrees because I always find my angle first. And then, even though this sounds fancy, I'm just going to make a ratio. 18 over 12 is equal to 13.5 over X. I get 18X is equal to 12 times 13.5, which is 162. And then I divide, and X is equal to 9.